temporary voltage drop to 60 volts in a single-phase electrical system after a power outage during a thunderstorm can be attributed to several potential causes on the utility side. Firstly, an open neutral conductor could be the culprit. The neutral conductor's primary function is to carry the return current in an electrical circuit. If this conductor becomes disconnected or damaged, it disrupts the balance within the electrical system. This imbalance can lead to a reduced voltage on one of the phases, explaining the observed 60 volts reading. Secondly, a faulty transformer could be responsible. Transformers are essential components in stepping down voltage from high to low levels for safe residential use. If a transformer malfunctions, particularly if there are issues with its windings, it can cause significant voltage irregularities. A damaged transformer might not provide the correct voltage output, resulting in reduced voltage on one or more phases. Thirdly, an overloaded circuit could be the reason for the voltage drop. When a circuit is overloaded, it means that an excessive amount of current is flowing through it. This excessive current draw can cause the voltage to drop below the normal level. During a thunderstorm, there might be increased demand on the electrical system due to the use of more appliances or lighting fixtures, potentially leading to an overload situation. Fourthly, loose connections in the utility distribution system can contribute to voltage instability. Over time, connections can become loose or corroded due to environmental factors or general wear and tear. Storms can exacerbate this issue, causing connections to loosen further. These compromised connections can lead to erratic voltage fluctuations, including reduced voltage. Fifthly, temporary switching operations performed by the utility company could be the cause. During maintenance or repair work, utilities sometimes temporarily switch the distribution system to a single-phase configuration. This temporary change can result in reduced voltage on the affected phase for a limited duration. Finally, other electrical faults within the utilities network, such as short circuits or ground faults, can lead to voltage irregularities. These faults can disrupt the normal flow of electricity and cause unexpected voltage drops. It is important to note that such voltage irregularities are often temporary and resolve themselves once the underlying issue is addressed by the utility. However, it is crucial to report the problem to the electricity provider to ensure that they are aware of the situation and can investigate it thoroughly. This allows them to identify the root cause of the voltage drop and take appropriate action to restore the system to its normal operating condition. Ignoring voltage irregularities can potentially lead to damage to electrical appliances and equipment, as they are not designed to operate under such conditions. Prolonged exposure to low voltage can cause motors to overheat and burn out, electronic devices to malfunction, and lighting to dim or flicker. Furthermore, voltage fluctuations can also pose a safety hazard, increasing the risk of electrical shock or fire. By reporting the problem promptly, it can help prevent further damage and ensure the safety of yourself and others. The utility company will typically send out a technician to investigate the issue and take necessary corrective measures. This may involve repairing or replacing damaged equipment, tightening loose connections, or reconfiguring the distribution system. Once the underlying problem is resolved, the voltage should return to its normal level and the electrical system should operate as expected. It is also worth noting that voltage drops can sometimes be caused by issues within the home's electrical system, such as faulty wiring or overloaded circuits. However, in this case, since the voltage drop occurred immediately after a power outage and affected the entire house, it is more likely that the problem originated on the utility side. Nevertheless, it is always a good idea to have a qualified electrician inspect the home's electrical system periodically to ensure that it is in good condition and meets safety standards. This can help identify and address potential problems before they lead to more serious issues. In addition to the potential causes already mentioned, there are a few other factors that could contribute to voltage drops in an electrical system. These include the distance from the power source, the size of the conductors, and the presence of any voltage regulators. The farther a home is located from the substation or transformer, the greater the voltage drop that can occur. This is because the resistance of the conductors increases with distance, causing more energy to be lost as heat. To compensate for this voltage drop, utilities may use larger conductors or install voltage regulators along the distribution lines. Voltage regulators are devices that automatically adjust the voltage to maintain a consistent level. They work by increasing or decreasing the voltage as needed to counteract any fluctuations. If a voltage regulator malfunctions or is not properly adjusted, it can contribute to voltage drops. The size of the conductors used in the electrical system can also affect voltage drop. Smaller conductors have higher resistance than larger conductors, which means that they will experience a greater voltage drop for a given amount of current. For this reason, it is important to use conductors that are appropriately sized for the load that they are expected to carry. The National Electrical Code, or NEC, provides guidelines for conductor sizing based on the ampacity of the circuit. Ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The NEC specifies the minimum conductor size required for various ampacities in tables such as 310.15b16. These tables take into account the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. In addition to conductor sizing, the NEC also addresses other aspects of electrical system design and installation such as grounding, overcurrent protection, and wiring methods. Following the NEC guidelines is essential for ensuring the safety and reliability of electrical systems. When troubleshooting voltage drops, it is important to consider all of these factors, including the distance from the power source, the size of the conductors, and the presence of any voltage regulators. A systematic approach to troubleshooting can help identify the root cause of the problem and determine the appropriate corrective action. Some common troubleshooting techniques include using a voltmeter to measure voltage at various points in the circuit, inspecting connections for looseness or corrosion, and checking the ampacity of the conductors to ensure that they are properly sized. If the voltage drop is caused by a problem on the utility side, such as a faulty transformer or an open neutral conductor, the utility company will need to be involved in the repair process. In these cases, it is important to cooperate with the utility and provide them with any information that they need to diagnose and resolve the issue. Once the problem is resolved, it is a good idea to verify that the voltage has returned to its normal level. This can be done by using a voltmeter to measure the voltage at various outlets and appliances in the home. If the voltage is still low, there may be other underlying issues that need to be addressed. In addition to voltage drops, other types of power quality problems can also occur, such as voltage surges, voltage sags, and harmonic distortion. Voltage surges are sudden increases in voltage that can damage sensitive electronic equipment. Voltage sags are temporary decreases in voltage that can cause equipment to malfunction. Harmonic distortion is a type of electrical noise that can interfere with the operation of electronic devices. Power quality problems can be caused by a variety of factors, including lightning strikes, switching of electrical loads, and the presence of nonlinear loads. Nonlinear loads are devices that draw current in a non-sinusoidal waveform, such as computers, electronic ballasts, and variable speed drives. To mitigate power quality problems, various types of power conditioning equipment can be used, such as surge protectors, voltage regulators, and harmonic filters. Surge protectors are designed to protect against voltage surges by diverting excess voltage to ground. Voltage regulators can stabilize voltage by maintaining a consistent level. Harmonic filters can reduce harmonic distortion by filtering out unwanted harmonic frequencies. Choosing the right type of power conditioning equipment depends on the specific type of power quality problem that is being addressed. For example, surge protectors are effective for protecting against voltage surges, but they do not provide protection against voltage sags or harmonic distortion. Voltage regulators can address voltage sags and fluctuations, but they do not protect against surges or harmonic distortion. Harmonic filters are specifically designed to reduce harmonic distortion, but they do not address voltage surges or sags. It is also important to ensure that power conditioning equipment is properly installed and maintained. Surge protectors should be installed at the point of entry of the electrical service and at individual outlets where sensitive equipment is connected. Voltage regulators should be installed in a location where they can effectively stabilize voltage for the entire circuit or system. Harmonic filters should be installed in a location where they can effectively filter out unwanted harmonic frequencies. Regular maintenance of power conditioning equipment is also important to ensure that it is functioning properly. Surge protectors should be checked periodically to ensure that they are still providing adequate protection. Voltage regulators should be calibrated regularly to ensure that they are maintaining a consistent voltage level. Harmonic filters should be inspected periodically to ensure that they are not clogged or damaged. In addition to power conditioning equipment, other measures can also be taken to improve power quality. These include using properly sized conductors, minimizing the distance between the power source and the load, and avoiding the use of excessive extension cords. Properly sized conductors can reduce voltage drops and improve the efficiency of the electrical system. Minimizing the distance between the power source and the load can also reduce voltage drops. Avoiding the use of excessive extension cords can reduce voltage drops and prevent overheating. Finally, it is important to be aware of the potential for power quality problems and to take steps to mitigate them. This can help protect sensitive electronic equipment from damage, prevent equipment malfunctions, and ensure the safety and reliability of the electrical system. In summary, a temporary voltage drop to 60 volts in a single-phase electrical system after a power outage during a thunderstorm can be attributed to several potential causes on the utility side, including an open neutral conductor, a faulty transformer, an overloaded circuit, loose connections, temporary switching operations, or other electrical faults. It is crucial to report the problem to the electricity provider to ensure that they are aware of the situation and can investigate it thoroughly. This allows them to identify the root cause of the voltage drop and take appropriate action to restore the system to its normal operating condition. Ignoring voltage irregularities can potentially lead to damage to electrical appliances and equipment, as they are not designed to operate under such conditions. Prolonged exposure to low voltage can cause motors to overheat and burn out, electronic devices to malfunction, and lighting to dim or flicker. Furthermore, voltage fluctuations can also pose a safety hazard, increasing the risk of electrical shock or fire. By reporting the problem promptly, it can help prevent further damage and ensure the safety of yourself and others.